Hey everybody, this is Larry. This is me doing the daily problem for day 23 of July. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's problem. So, a new problem. I haven't done this one before. Nice. So I'm excited about that. Just a quick interruption, I guess, or whatever. Did the contest earlier today and I finished top 10 without counting the Chinese server, so that's good. Always celebrate your victory, so I'm gonna give you permission to celebrate as well. But yeah, alright, today's problem is a 94 all possible full binary trees. Given integer n, return a list of all possible full binary trees with n nodes. Each node of each tree in the answer must have node dot value equals 0. Each element of the answer is the root node of one possible tree. You may return the final list of trees in any order. A full binary tree is a binary tree where each node has 0 or 2 children. Okay, so 2, 5. I mean, yeah, I mean, I think this is just a brute force problem, right? Oh, I'm not gonna lie. Initially, I thought it was gonna be counted and numbers, but I guess this is full. Is it still like a variation of it? If I have to guess, to be honest, I think it probably still is because I don't know. Maybe my math is bad. It probably still is. It's just that you have to be a little bit more careful. I think it's probably like something like, if I have to guess, and I will do the proofs and stuff like this soon, but off my head, if I have to guess, it may be like n over 2, like n over 2, the Canadian number or something like this is probably the answer, because my intuition is that, and this is something that you recognize just from general. What happened to my mouse pad? Why is it dirty? It's kind of nasty, actually. Okay, but yeah, but the structure is such that the sum of possibilities, right? The sum of, okay, left has 1 node, left has 2 nodes, left has 3 nodes, and then the right side we have n minus 1 minus left node and so forth, right? So all that. Here, I think you do the same thing, except for on the left side you have 1 node, on the left side you have 3 nodes, because you cannot have 2 nodes, and then on the left side you have 5 nodes, and then 7 nodes, and so forth, right? So in that way, the structure is very similar to Catalan. So if I have to guess, it's probably just gonna be like n over 2, maybe plus or minus 1 or something like this, and that will be the Catalan numbers, right? But in this particular problem, we're not trying to get the number, we're trying to get the actual tree, so we have to kind of construct it anyway. And because I was initially, one thing that I was sanity checking, and just to kind of give you a little bit of an insight of how I think about these things on top of what I already done, is that initially I was like, oh, it's just probably Canada numbers, and I saw n is equal to 20, and I know that the 20th Canada number is pretty big, but now that we kind of thought through it a little bit, we can see that it is maybe the 10th or 11th Catalan number. Let me just search so that you can have something to Google on. And I'm like, oh, that is within reason to construct, right? So yeah. Okay, so then, like I said, then we can do something like this. We can construct x, right? This is kind of really awkward in general, but to actually build the tree, but yeah, so basically if x is equal to 1, then you just return tree node, right? Otherwise, maybe this is an array of it so that we have to do some stuff. Yeah, okay. And then otherwise left, okay, so then we have a and then otherwise we have for I in range of, and maybe we call it left, right? So the number of left nodes is going to be Let's see. Can it be 0? Am I confusing it? Because I wanted to write something. Well, maybe it can be 0, but it depends on n. In fact, they didn't give you any even numbers. What does n is equal to 2 look like? N is equal to 2 is just, yeah, one node had 0. So I guess it's okay. Maybe I was going to do something like clever with respect to like just getting all the odd numbers, but maybe we just go from 0 all the way to x, and then it's fine, and then we just, you know, do it that way, right? So yeah, if x is equal to 0, return to maybe, right? So yeah, so then right is equal to x minus left minus 1, and then now maybe we have a list of results, right? The list of results would contain a new tree node where the value is 0. Oh, and I think the default is 0 anyways, that's fine. Left is equal to I guess we can't quite write it like that. This is kind of messy, but basically maybe left trees is equal to construct left, right trees is equal to construct right, and yeah, and then now for maybe, you know, in zip oh no wait, it's not a zip, right? It's a product. So L in left trees for R in right trees, enter that append. We have a new tree node, value 0. We have an L and a right on the left and on the right, right? And we return. And then that should be it, right? Construct X, is it? Or N? Unless I have some weird issue. Yeah. Yeah. And this should cover all the cases. Can you have 2? I guess you can have 2. So maybe my initial assumption was wrong with the even numbers. That was trying to do too much. And yeah, as you can see, this is clearly just Catalan numbers. Each node, with each node, I feel like something's a little bit off. Like, why is this right? Let's try 10 and 20 and 2. I don't know. I mean, it may be that my even numbers are wrong. That's why, you know. And now it's looking like it may time out. That's actually, I think, yeah, because what we're doing is the 20th, or like the calendar numbers. I think something's wrong with the, okay, so 4 is no good. Yeah, I think that's the thing that I was trying to think. Can you actually have 2? Because then now one of the nodes have 0, right? So this can't even be possible. But I didn't do anything tricky about it, so why is it that... How does this even work? Did I do something right by accident? This is still like the calendar numbers though. But, why is this so slow? I don't know that I can do any better. If you have to return the actual trees. That is actually surprising. I mean, this part I could have done something like, if n mod 2 is equal to 0, we can return an empty array. But so that part we can optimize the way, but And I'm surprised that it's not fast enough. Am I doing this silly wrong? I guess one way that you can do it is reuse these nodes. Reuse the, but that's like, this feels almost cheating. So you can probably do something like cache or something, right? Well, 20 is fast, but. Wonder if that's fast enough. That makes it fast enough. It is very awkward. Let me give it some mid. So the reason why this works is actually kind of tricky to explain if you don't have a good understanding of references. And it's kind of weird that you need to make this optimization. I don't know that. Yeah, I mean, I don't know that that's great, but the idea basically is that you're using shared memory as you kind of, so now it's wild actually, the way to kind of think about it. It's that you reuse a lot of the memory and calculations, which is fine, but I guess it is the way to do it. But that is wild that you get to reuse it though. I don't know. So yeah, so what's the complexity, right? Well, Canada numbers is what is the form? Let me Google that real quick. It's been a while. Yeah, it is just, that's right. It's all of two. It's 2n choose n is roughly speaking the Canada numbers, or it actually exactly is. It's just that I might be off by 1. So that means that, you know, this is going to be equal to 2n factorial over n factorial over n factorial, right? Something like this. And so you know, that's basically the complexity, which is kind of really rough to say. It grows pretty fast, as you can see, exponentially. So yeah. Yeah, I don't know. I don't know if I'm saying anything that makes sense today, but yeah, that's all I have for today. Let me know what you think. This is definitely a tricky problem if you haven't done it before, especially if you need the optimization. I'm kind of like, I don't feel like you should need the cache. Am I doing it well? But yeah, I don't know. Why do you need memorization for this? But yeah, like I said, it's gonna be exponential due to the. I mean, okay, I know I could do DP, but but the thing is that the DP isn't necessarily. Because I think the tricky part about explaining this is that the DP isn't necessarily there for the count or whatever, but actually there for memory reasons, because basically you're not allocated. So the time you save is actually from the fact that you're not reallocating the memories every time that you call the same function. But maybe I'm lying. Maybe I'm like just really wrong on this one. What? Give me OEIS. Okay. What is the 19th Canada number? Or even the 10th? Yeah, so you can kind of see that, yeah, it only has like 40, that's what I thought. Only 4,000 of them. But it's just this idea of not recreating memory usage. I think that's why. And it's kind of weird because you can also The other thing that you can see is that you can actually cache it on a higher level, which is probably what people do for the submission time. But yeah, I don't know. It's very weird. That's all I have for this one. Let me know what you think. Stay good, stay healthy, do good mental health. I'll see y'all later and take care. Bye bye.